All right, welcome everyone. This is the time when you might want to put your headsets on, and I might need confirmation from just one person that you can actually hear me. All right, perfect, great. So, welcome everyone. This is the session where we will discuss what's new with AWS's threat detection services. My name is Himanshu Verma. I'm a principal worldwide security specialist with AWS, and I'm joined with.
I'm Ryan Holland, and I lead the GuardDuty security engineering team.
All right, so let's dive in. TDR 202, the topics we will cover today, an overview of AWS's threat detection and monitoring services domain. What all are the services that we have in this domain? Some of the new features and new capabilities, including some of the ones that have been just announced in the keynote today. Uh, we will give you a brief demo overview of these new features as well, and then we'll leave some Q&A. First and foremost, I want to highlight that we're actually hearing from customers the need for continuously integrated security, which means security that is actually integrated within the workloads. Our goal has been to ensure the simplicity when it comes to managing security as well as operationalizing security. How can we make sure that customers have visibility into whether it's detecting threats and or suspicious activity and or reporting any abnormal findings without the need to go in to the logs and or operationalizing the logs. So that is one of the core principles in making sure that our threat detection and monitoring services are absolutely simple and easy. The second main goal is to ensure that both the DevOps persona or the developer persona, as well as the security persona can benefit from these services. And we are looking to integrate those workflows by providing this simplicity in our services. So when we look at our threat detection and monitoring domain, there are these 5 key security services. First and foremost, our primary threat detection service is Amazon GuardDuty. GuardDuty is our threat detection service that can highlight and or enumerate any abnormal activity, any suspicious activity, as well as any malicious activity throughout your accounts, your workloads, your entities such as IAM, as well as newly added workloads such as EKS and S3 or data stored in S3. It's a continuously monitoring service, so once enabled, all customers have to do is review the findings and act on the findings. The second service in that domain is Amazon Macie. So Macie is our actually data protection as well as threat detection service because it helps monitor any controls that you have on your S3 buckets, as well as helps monitor what is your security posture around the data stored in Amazon S3. The third service is Amazon Inspector. Amazon Inspector is our vulnerability management service. It helps identify operating system as well as software vulnerabilities in instances as well as container workloads and is continuous as well. So once enabled, there's very little operationalization that's required. It just scans your workloads automatically as well as reports the vulnerabilities. The findings from all of these services are available through EventBridge so that customers can operationalize those and or orchestrate downstream automation, whether integrating with third-party tools and or with their security operations. The best recommended practice is to leverage our fourth service here, which is AWS Security Hub. Security Hub is our centralized security monitoring as well as security cloud posture assessment service. So Security Hub is evaluating controls as your AWS workloads are growing. It's evaluating controls in the backend and reporting any non-adherence to security best practices, as well as it's aggregating findings from native AWS security services and third-party tools to give you one place to go and view all of those findings, and then normalizing all those findings into Amazon security finding format. That then helps security teams to easily take actions with one parsing format and easily write rules so that you can take automated response and remediation actions. And then finally, the fifth service in that domain is Amazon Detective. Amazon Detective is our service that's dedicated towards the security and or the security operations center persona. It helps investigate threats as well as find out the root cause analysis of the events that you might want to dive deeper into and understand how long have they been manifesting in your environment, and or what has been the root cause analysis behind those events, so that you can take appropriate response and remediation actions. Now, the core value proposition of these services is not only the features that they're providing, but also the native integration that comes with AWS workloads. For example, these services are enabled at the AWS account level. AWS account is your logical boundary where you have AWS workloads, your IAM entities, your VPC your VPC domains, and or policies around that. And then you have your storage, you have your databases, you have container workloads. Simply by enabling these services at the AWS account level, you can get the coverage that these services provide for those workloads. That requires no enablement of any additional logging and or operationalization. So as we go through the demonstrations, we'll show you how easy and simple it is to enable these services, and that is really all that's required to get the value from the services. So the first best practice that we're going to walk through is deployment at scale. How can you deploy the threat detection and monitoring using these services at scale? Over the course of period, what we've done is that we've enabled these services to now not only be enabled at the AWS account level, but also be managed from a centralized management account using the native AWS organizations integration. AWS organization is a best practice for organizations to leverage, where you can designate or delegate a centralized management account and then easily onboard multiple member accounts to a service. AWS organization integration is now available with all 5 of those services, which makes it easier for security teams to have one centralized account and makes it easier to manage these services, makes it easier to onboard and offboard the services, as well as aggregate the findings into one security account. Depending upon your organization needs and then the personas that you have, you might have the same security account and or different accounts for each one of these services. For example, data governance and data protection organizations or teams might need a centralized account for Amazon Macie, versus security teams might need a centralized account for GuardDuty and or Inspector, and which is something which is all feasible using AWS organization. So let me give you a glimpse of that demo and how that looks like. As we are aggregating all these findings into Security Hub, I'm showing you this interface from AWS Security Hub. Under the settings in Security Hub, if you go to the Accounts tab and you have AWS organizations enabled, you'll have the ability to designate or delegate a centralized management account. And once that's enabled, you'll see all of the member accounts listed right here. You can easily select one or many of these accounts, and then you can choose to enable the service on all of these accounts or subset of these accounts. Additionally, if you're using these services across multiple regions, as AWS organization is a regional construct, in Security Hub, we've now added the feature where you can go in and designate a centralized region or an aggregation region as well. This allows you to not only aggregate findings across multiple accounts using AWS organization, but also allows you to aggregate findings across multiple regions by designating a home region or a centralized region. And all of your other linked regions will automatically then send findings into that region. We also have the ability to auto-enable accounts as well as auto-enable features in these respective services. That makes it easier as new accounts are getting added to your organization or to your AWS accounts, and new resources are coming in, automatically these services will be enabled. So this is the best way to enable these services at scale.
Perfect. So the next part, we'll move in and look at some of the new new features that have come into GuardDuty. So earlier this year, actually earlier this month in July, we released a new update to our S3 protection. So we'd originally launched the first version of S3 protection last year, and we revamped the capabilities with a new and improved deep learning model that allows us to give more accurate detections, as well as identify and give customers context about what the model thought was unusual. So this is very similar to last year when we re-released the CloudTrail management event detections under this model. This is a very similar model that we've now adapted for S3 data events. So with S3 data events, we're looking at the get, list, puts, delete data calls, how users are interfacing with S3 buckets and objects. And what we're looking for here is suspicious or really unusual activity. And with these new models, we have a bunch of really great features that allow us to be more accurate and also reduce some of the noise. So we're able to look at activity across an organization and understand how the different users interface with S3 buckets across different accounts, as long as they're in the same AWS organization. We also now have volumetric detection. So looking for unusually high numbers of API GET calls to understand and look for data exfiltration from buckets. And we do this by profiling how all the users and roles within your accounts are interfacing with different S3 buckets, and what ones do they normally access, where do they normally access them from, what are the volumes and types of events that we typically see for an individual principal. So when we did this re-release on these, there was now 19 different detection types that, again, look and are mapped to the MITRE attack framework to help you understand whether or not, which part of the attack chain that would be coming from. And again, one of the key features on this is when we do give you one of these anomaly detections, it will include in the finding a lot of context that wasn't there previously that helps you understand what specifically about that request the model felt was unusual or anomalous for that particular user or bucket combination. So we also, earlier this year in February, we launched our fourth data set, which is EKS protection. So this allows us to look at EKS audit logs. So if you're running EKS on the controller, there's an API that allows you to interface with the Kubernetes control plane. And there's a lot of powerful API calls that you can make, and you can configure. That's how you add new pods or how you set up your namespaces. And you definitely should turn on EKS audit logging. But even if you do not have that enabled, GuardDuty can still get access to this data stream, similar to all of the other data sources. So when you have VPC flow logs or DNS query logs, you don't have to enable those in your accounts. GuardDuty gets those from a separate independent stream on the back end that allows us to see this log data regardless of whether or not you've enabled it in your account. And the same goes with EKS audit logs. And this allows us to look for unusual activity, no malicious activity, by applying threat intelligence. So we look at threat intelligence that we get from some of our partners, as well as threat intelligence that we internally develop ourselves. And then we apply some machine learning models to understand whether or not this is unusual behavior. And then again, as Himanshu mentioned, all of these findings go out to EventBridge. This allows you to send them to a downstream SIEM or automation, as well as to Security Hub, so you can consolidate that with other security findings from other products that you're using. Or you can actually pivot directly from a GuardDuty finding into Detective if you want to do a deeper dive investigation on that finding and see other relevant events that were associated with that. So I want to give a little bit more detail on the EKS findings that we recently released. So with EKS audit log protection, again, we're looking at audit logs around three different areas. So the first one is policy mistakes. So with Kubernetes, you have the ability to allow anonymous access if you'd like. It's not recommended. Also, you can open it up to the internet versus having it only be accessible by certain IPs from a security group perspective. And there's also other configurations like privilege containers or adding the administrator account to, or admin privilege to a service account. The second category is really like no malicious access. And that's where we've seen an API request that came in and it was successful and it was unauthenticated. So from a policy perspective, you allowed unauthenticated access, and then someone has actually found that on the internet and is starting to actually use that API, and we're seeing successful requests that are not authenticated. Or other times that we see, once they figure out that it allows unauthenticated access, we start seeing future access come from Tor networks or other IP addresses that we know are generally malicious based on our threat intelligence. So again, this this is something that we can pretty well say that someone has actually found a cluster that you've made a policy mistake on and is now likely doing something bad. The third one is really more suspicious behavior. So on this category, there are use cases where there's legitimate needs to have privileged containers, for example, right? If you're running some sort of a firewall tool or other types of networking components, they might need privileged access. However, adding a new privileged container can give you a lot of power. It can sometimes also have access to host mounts. And so we will learn which one of the pods within your deployment you generally do that, and we'll stop giving you alerts for those. But generally, anytime you make a new pod that's going to have privileged access or host mounts that we consider sensitive, we'll generate a finding on that just so you can understand that that's taken place. And then again, like all of our other findings, we will map these to the MITRE attack framework to help you understand which part of the attack chain this is part of. And then the last new component on GuardDuty, if you were in the keynote, you probably heard about this. So just this morning, we officially launched GuardDuty Malware Protection. And the way that this service works is it's a fully managed detection service that when you enable this part in GuardDuty, we have mapped a set of findings that are indicative of a possible infection from malware. So it's not every GuardDuty finding, but if you have a C command and control finding, if an instance is doing Bitcoin mining, contacting Tor, right? All of the different components that are very indicative of a potential malware infection. Whereas before you would have to go and immediately start trying to investigate that on the instance itself, we will now in the background snapshot that volume, make a copy of it into our Surface account, and rehydrate into a volume that we will run a malware scan against it. We're able to detect a whole host of different types of malware. And if we identify any malware, it will generate a net new finding for you in GuardDuty. It will show you the path of where that particular piece of malware was found, what type of malware it was, and which finding triggered us to do that scan. Again, all of this happens automatically without any intervention on your part, and there's no agents to install, and so it also has no impact on the performance of your system as well. I'll walk you through a quick demo on how that all looks. So again, kind of taking over from where Himanshu was, this is also a feature that you do have to enable if you're an existing customer. So within organizations, you do have the ability to choose which one of our sub-features you want automatically enabled. So if you want S3 protection, EKS protection, and now malware protection automatically enabled on any new accounts that join your organization, you can easily configure that here as well. I'm going to show you a walkthrough of kind of some of the EKS protections and how it leads to malware detection. So in this case, we actually opened an EKS cluster up to the internet. I don't recommend you to do that. But as you can see, you'll get a policy finding that tells you, I allowed anonymous access to an admin role. This is, again, don't do that. And what you'll quickly notice happening is people will start discovering that. So people on the internet start scanning, and we start seeing successful access to some of the APIs that are coming in unauthenticated. And then we'll start seeing some persistence. So they'll start using the capabilities that I've basically given to the entire internet to start making changes on my environment that will allow them to then start launching new pods. The new pods that they launch, unsurprisingly, are going to start doing crypto mining. So this tends to be a favorite post-exploit action we see typically, is people will like to drop Bitcoin miners on the instances. And as you can see, they actually created a couple. So we got two separate findings that now I have multiple pods that are generating crypto mining. And then further, we see them start to do even more activity. I made a very privileged role public. So they're starting to do things that we're going to impact and then access our credentials. So you can see in this case, they started accessing the secrets namespace in order to list and to get my secrets. And then ultimately, because of this activity, we in the background kicked off a malware scan because that host was doing crypto mining, and crypto mining is one of the finding types that can trigger a malware protection scan. This then went and on the back side did a malware scan for this volume. And as you can see, the file that we detected is XMRig, which is a very common crypto mining tool that we tend to see pretty frequently. Again, you'll get all the information about where this instance, about the instance itself, its tags, where the volume is, and where that file was on the volume itself. Your malware scans are also visible separately over here. So every time we have a GuardDuty finding that has triggered a malware scan, we have a separate record of those. And you can again go and look at these and see which finding ID triggered that and what the result was for any of this individual malware scans, the volume and the files that we found.
Moving forward, we want to talk about how customers can actually investigate some of these events as well. One of the core capabilities that GuardDuty provides is highlights findings, and the next best practice is to actually take action on those findings. So typically using the contextual information that is available in the finding metadata, you have enough information to go and act on that. Or more mature security operations center teams or threat analyst teams would want to dive deeper into finding out what was the root cause analysis, how long has that event been there. So this is where Amazon Detective comes in. Amazon Detective is targeted towards providing 3 key benefits to our customers based on their customer personas. First and foremost is the finding and alert triage. As we highlighted, GuardDuty automatically, once enabled, starts providing you findings. In addition to those findings, there's also network and API activity that is consistently happening in your accounts or your workloads. Being able to identify which of those events is actually a threat and or something that you need to act on is where GuardDuty can help investigate. Secondly, incident investigation, which is now you've detected that there is a potential malicious activity from an IP address that was reported in a botnet, or from a domain or a DNS instance that was reported by our threat intelligence, and you want to now go in and investigate how long has that been manifesting itself in your environment, and or are there other resources that potentially might have been impacted by that IP address or by that source. And thirdly, the ability to do threat hunting, which is ability to link and identify how those entities are connected and what is your potential blast radius for the incident. Now, typically customers are able to do this, but to be able to do that, you will have to do a lot of operationalization. You'll have to have access to raw logs, which are typically in the form of flow logs such as VPC or DNS, APIs, CloudTrail APIs, and that could, one, get expensive, and secondly, can get operationally costly and expensive to correlate all that information together. What Amazon Detective does is that once it's enabled, it's building a behavioral graph on behalf of the customers and their accounts. Now, not only is it building a behavioral graph, but it's also retaining all that activity over a period of 12 months, which means using a feature called Scope Time, you can actually go back as far as 12 months to visualize in the user interface of Amazon Detective how all these entities are interlinked and correlated. The example that's represented here is that you can originate your journey from GuardDuty finding, and then from there you can go to the resource that was affected or the user whose identity and or IAM access and the session role was assumed, and then what actions were performed by that entity and on what resource. In this case, since today we announced that GuardDuty now supports EKS support as well, you can actually now investigate clusters and pods using Amazon Detective. So this is a new feature that we just launched today. Amazon Detective already supported instances, data stored in S3, as well as investigating findings that were originated in GuardDuty. And then with GuardDuty's malware protection launch, another new feature that has been added is the support for EKS investigations in Amazon Detective. So this now allows you to quickly analyze and investigate or identify the root cause of malicious or suspicious behavior in container workloads. You can review EKS-specific activities such as pod volume patterns, container service user activity, and you can also investigate what user or what IAM entity or what IP address was interfacing with those cluster workloads. To highlight this, just to simulate the demonstration, you can start your journey either from the finding that you have been reported in GuardDuty, or you can navigate to the Amazon Detective console, and you can start your journey from there by selecting a resource or selecting an entity. In this case, I'm taking the same example that Ryan was highlighting, where the admin gave access to an anonymous user from a remote IP address. Now, this IP address and this information will also be reported in the contextual details or the JSON of the GuardDuty finding, from where once you navigate to the detective console, you'll be able to see all the associated entities. For example, the AWS account that IP address is associated to, the resource that it's connected with. So in this scenario, we're starting our investigation from GuardDuty. Once I click on the Kubernetes pod details or the subject details, now you can verify what action has that been taken. And then using the scope time, which is on the top right of the screen, you can adjust whether you want to view this activity in the last 30 days or last 6 months or as far as last 12 months. And that gives you the ability to also scroll down and to the Kubernetes API activity, and Detective will automatically set the scope time accordingly for all the activities that are recorded in that time. Moving forward, you can see in this panel that using that IP address, I can also expand to view what actions or what actual API calls were made from that IP address. So here you can see another activity, or you can observe that IP address, which was reported in the GuardDuty finding, is trying to create a role binding rule into that pod. You can also view additional API calls, not only create, but the get calls that are associated with that. And again, this is all available by simply adjusting the scope time on the top and or the details in the API activity. Additionally, when I switch back to Kubernetes activity in the console, you can view here that there is a pod named Reader Debian, which is the pod that was involved in that IP address associated to that. And the fact that this IP address made a call to that makes us believe that that finding was assigned to this pod in your credentials, and they're trying to spin up a new Debian instance in that pod. Moving forward, if you now go into your role and IAM entity for that account, you can pivot there and also view what are the actions that were taken as part of this compromise. And then as GuardDuty finding was reported, where there was Bitcoin mining or XMRig instance available, Detective will also be able to show you that before that, this IP address tried to list the secrets from that container workload. So using this information, again, it gives your threat analyst the ability to dive down into these actions and or the appropriate use cases and contain that instance either in that time and or take actions on all the associated resources where that instance, where that particular investigation leads to. And finally, just to show you here, you can also filter what are the API calls or functions. In this case, this has been filtered by execute call. This will report there are no results here, so it has not been executed yet. But if we go ahead and view the details, you'll be able to see that the specific Debian container image with the hash that was reported in the previous screen is a suspicious Reader Debian pod. Using Detective, again, one of the other things that Detective is doing is collecting all this information on behalf of you and then correlating that. So you can use wildcard search as well as easy search to look for anonymous access and or specific API call actions. We search for a web app call, and that is where we find another IP address that has reported that web app call running a cron job on that container image. The anonymous user created that cron job and passed a pod name web app, which is reported here. And then when we dive deeper into that, we can see that XMRig which is where the crypto mining image was created and associated with the container pod. And then finally, the anonymous user created a cron job, patched the pod. The web app pod had containers from the crypto mining image, and the XREM image is not deployed anywhere apart from this particular resource. So this tells you that what was the blast radius and how many resources are associated with that particular crypto mining instance. So you can see, number one, the root cause has been identified, which is the unusual Debian image, which was initiated. How the scenario happened is that the container extracted the secret token from the EKS admin. It was then able to grant that access to the anonymous user. And then the impact was creating a cron job. And then it also modified the web app pod with a crypto mining container image. So that gives you the ability using Detective to now investigate the root cause as well as contain that incident, all by simply enabling the service and then being able to visualize that graph database in the Detective console.
So the next service we want to talk about is Amazon Inspector. So Amazon Inspector, if you're not familiar, was actually one of the first external security services that we launched back in 2016. At reInvent last year, in case you missed it, we relaunched Inspector with a whole new version that was really rewritten from the ground up. And it has a lot of new and great features that enable customers to use it very much like a lot of the other ES services that we've talked about so far. So the first and foremost is it allows you to really simply get centralized visibility of your vulnerability space across all the accounts that you have, again, in your AWS organization. We no longer require a dedicated Inspector agent. Rather, Inspector uses the Systems Manager agent in order to collect information about the packages that are installed on a particular instance. And we also have a direct integration to Elastic Container Registry to understand any vulnerabilities that exist for your container workloads as well. A lot of our customers are already using Systems Manager. So if you're already a Systems Manager customer, you don't have to install anything or do any changes to your environment in order to enable vulnerability assessment within Inspector. However, we will also give you an understanding about what your coverage is. So if there's instances that aren't managed, for example, or running an unsupported operating system, those will be flagged in the console. So that way you have central visibility, not only to all the vulnerabilities that we're able to see, but to any gaps in where you're not currently getting coverage as well. Like a lot of our other services we've talked about, it's got that one-click continuous monitoring. So one of the other challenges often we see with vulnerability assessment is when do you run vulnerability scans? A lot of times traditional tools will do things like weekly or monthly scans. And in an environment like AWS, where workloads are constantly coming and going, being scaled up and scaled down, doing weekly or monthly scans doesn't make a whole lot of sense because you might miss workloads that were running for a long period of time, but weren't running at the exact moment when you decided to run those scans. So no longer do you have to schedule or set up or when you're going to run these scans, with continuously assessing your environment for vulnerabilities, and that's across instances as well as container images. As we understand new vulnerabilities that are coming in, we align that with what package data we have on your instances. Similarly, if the packages that are on your instances change, we'll then cross-reference that against the data that we have from the vulnerability feeds. So this gives you up-to-date, near real-time visibility into the vulnerabilities that you have across your environment. We also give you some very good context. So we apply all of the metadata that we can get across the instance. So which accounts are they in, any tags that are on the instance, as well as what we call our Inspector score. So Inspector score looks at a vulnerability more than just the CVSS score, but we're also looking at things like, is this publicly reachable? Right? So again, if I'm trying to prioritize how am I going to go and tackle any vulnerabilities in my environment, most security teams will tell you there's almost always more events than you can handle or have time to fix in a day. And so a lot of times it becomes a prioritization exercise. And so we try to help prioritize that by bringing the more critical vulnerabilities to the surface at the top. And we look at, again, a combination of, what is the vulnerability risk score from a CVSS standpoint, and then also apply other logic like, can this be reached from the internet? And we do that leveraging our automated reasoning tool, Zelkova, which allows us to see if an instance is reachable, even if it doesn't have a public IP address. So if it's behind a load balancer, for example, we'll still be able to recognize that it is reachable through a path from the internet, and also which ports it's reachable on as well. And so we apply all that together in order to come up with our risk score, again, to help give you the biggest bang for the buck. We'll also show you these vulnerabilities and map them to different constructs. So is it a container repo or an individual container? Which Amazon machine image has the most vulnerabilities? And then which machine image has the most vulnerabilities and is used by the most instances? So that's another way to look at this. So can I solve a lot of problems with one change by updating a single image, for example? And then again, like our other services, all of these findings go out through EventBridge. So you can automate response, go out to Security Hub, again, so you can have them in the ASSF format, and also take downstream actions from there. One other key output from Inspector is we don't just limit the information to the Inspector console, right? So security is everyone's job. And so we want to make sure that the developers, from a container standpoint, also have access to this. So a lot of times we see that container developers, they would like to know if their containers have vulnerabilities. They want to fix them too. And so rather than keeping this all just within the Inspector console, if you go to the Elastic Container Registry, if your container repo that you're in charge of has vulnerabilities, you can also view them there. This helps kind of take a step away, right? So your developers can immediately recognize that they've added a new container, it has vulnerabilities, and they can go and fix that right away, hopefully without even anyone from the security team telling them they need to do it. So again, like our other services, you'll notice this starts to look quite a lot. We have the auto enable feature. So you can do this across your org. You do have two options with auto enable. So you can do just EC2 instance, or you can also do containers image scanning. So when you do this, also, we have one other feature that we just recently launched. So when we originally launched this feature for ECR scanning, we only did continuous scans on container repos for 30 days. And really the logic there was most of these container repos, the containers get replaced and updated pretty frequently. And some customers didn't want to continuously scan older images. So you now have the option of changing that. So you can say 30 days, 180 days, or lifetime. So if you always want us to continuously rescan the container images forever, you can change that. Again, like I said, when we're one of the key things we're trying to do here is bring to the surface or bring to the top what are the most actionable things that you need to look at from a security perspective. So first is your environment coverage. So do I have Inspector turned on across all my accounts? If I have auto enable and turned on, that should always be 100%. That takes care of that for you as well. Again, if there's any instances that we are not getting telemetry from, so that means either the systems manager agent isn't running or it's an unsupported operating system. So we can highlight that so you can understand where you have gaps in your coverage. And then which of your repositories from an Elastic Container perspective are we also scanning. So just below that, you'll then see what are our highest risks from a vulnerability perspective. So these are either images or repos that present the highest number of findings. So we put a bunch of vulnerable containers in, and you can see this one in particular has a whole host of findings. So if I was trying to take care of a large number of risks at once, this is where I would start, right? And again, if you click on any one of these, you'll get a lot of detail about the finding, about the vulnerability itself, whether or not, where the file is located, where the vulnerability came from. So was this reported from NIST? In this case, it was from GitHub. And then again, what repo this was in, which account, which repo, and the image name inside the repo that generated this particular vulnerable finding. So I can also look at these in other ways too. So since I'm in the delegated administrator, I'm looking at this across all of my accounts. Again, I can go and kind of see which one of my accounts are generating the highest number of vulnerabilities for me. And then from an ECR perspective, and again, across all of the accounts, the repos that you might have, which repos are have the most containers with vulnerabilities in it, and allows you to drill down that way. And then which of the actual container images themselves present the highest number of vulnerabilities. And then another way I like to look at this too is by the Amazon machine image. So this is really important, especially in cases where you have a common base image, or if you're using auto scaling, you might have 100 instances that show the same vulnerabilities, but it's because they're in an auto scaling group that has 100 instances. And so by simply addressing the vulnerabilities on that one image, you can update and then remediate and patch all of those instances with a single action. So I mentioned we also wanted to make this viewable for the developers as well. So like I said, that was the kind of security persona view. If I'm the DevOps guy, or I'm the one that's in charge of running my containers, I can also go into my repo and click on See Vulnerabilities for an image that I've pushed. And these will show up shortly after you push the image. So as soon as you do a push, we initiate the scan. This will populate, so the developer can actually go and see this, see that they've pushed a vulnerable container image, and take action on that, hopefully without even ever having to involve security people as well.
As we move forward, one of the other key elements is the continuous monitoring and automated response and remediation. In all the services that we just highlighted, they can easily detect and highlight what are the findings and what actions need to be taken. This is one of the most critical aspects that we help customers operationalize their security operations, is to actually take actions on those findings. Most of the times, GuardDuty will have reported a finding, but if the customers are not taking actions on them, or there is no easy way to automate those response and remediations, then those findings will still persist and your workloads are still exposed. So Security Hub is our centralized monitoring as well as security posture assessment service. First and foremost, Security Hub is aggregating findings from all these services. We've natively integrated all these services with Security Hub. So all those events that you saw in either the GuardDuty console or the Inspector console with the detailed JSON and the contextual information, that all automatically can also be sent to Security Hub for aggregation. Additionally, we have been continuing to add Security Hub's integration range with a wide number of our partner products and services as well. So Security Hub today integrates with about 60 plus partner integrated services and products that you can also aggregate the findings from those products in Security Hub. More importantly, as you're adding new workloads in your AWS accounts, you want to be able to answer the question, are you secure, or are your developers following the security best practices? So Security Hub today uses a wide variety of controls in the backend, and these controls are continuously being added and enhanced. Over the last 12 months, we've added about 60 plus new controls in Security Hub. These controls are evaluations against security best practice standards. We've actually aggregated those standards into what is called internal standards in Security Hub, which are enabled by default when you enable the service. So two of the internal standards, AWS Foundational Security Best Practices, as well as CIS benchmarks, are automatically enabled. There's an external standard, PCI DSS, that's available as well. Evaluation of these standards will provide an executive score, looking at which you can easily infer what are the key areas that you need to address in those controls. Examples could be a secret key that has not been rotated over the last 60 days, or a bucket which has been publicly accessible and or has overly permissible IAM controls as well. So these are the controls that can provide you easy visibility into where are the high priority actions that you need to take. In addition to that, some of the key elements that Security Hub provides when it comes to response and remediation is normalizing all the findings into Amazon Security Finding format. That helps customers to enable automated remediation for those high severity configuration findings. You can easily write your own custom actions or custom rules within Security Hub, which will then invoke either step functions or Lambda, which are natively available within your AWS environment, that can then be invoked as runbooks or imported as runbooks. We actually have a GitHub repo where there's a lot of these runbooks are readily available with a collection of actions that can easily be imported into Security Hub and then orchestrated in the workflow of the findings so that you can act on them. Additionally, we also have downstream partner integrations in Security Hub as well. So not only integrations for sending findings to Security Hub, but then routing findings out into partner solutions. If your security teams are using a security incident event monitoring, a SIEM tool, or a security orchestration and automation response tool, you can actually send those findings into those tools as well. The big advantage, again, is the normalized standard Amazon Security Finding format. And then finally, integrating it into your ticketing and workflow tools, whether it's maintaining SLAs for your security operations and or being able to effectively communicate with the DevOps teams to prioritize where they need to take actions. Security Hub now provides these bidirectional workflow integrations with some of the ticketing as well as toolings that you can integrate easily. So let's take a quick look at what that looks like in Security Hub. As I mentioned, in the centralized console, once you enable Security Hub, you will notice that there is a collective overall score, which is an aggregation of how your two security standards are performing. The CIS AWS benchmark, as well as AWS foundational security best practices. There are controls that are being evaluated, which you can narrow down into each one of these and view what are the priorities or high severity critical as open issues that you need to address. We also categorize these by workload denomination to make it easier for the security teams to highlight this to their respective workload and or developer teams as to where these controls need to be addressed. All of these findings are aggregated. One of the other features that I highlighted earlier was the regional aggregation. You can also filter by region which region is exhibiting the highest criticality or the highest severity of these findings and filter them by region as well and aggregate them cross regions. Additionally, it gives you the ability to create your own insights. Insights could be a collection of these findings using custom filters and or aggregating them by resource or aggregating them by use case or your developer teams. And you can view that over a trending period of time. And then on the findings page, you'll view all of the findings where you have the ability to interface with them, manage the workflow, and view the details of what all is in the finding detail. You can very easily use these filters and either group them or filter them by product and or by resource. And finally, using the integrations page in Security Hub, you can easily integrate these findings either for incoming new data that comes into Security Hub or outgoing into SIEM tools and or your security operation tools. You do have the ability to define custom actions in Security Hub, which will then be a collection of your CloudWatch actions that can either invoke step functions or Lambdas. Once you've defined these custom actions, you can then automate them to be able to leverage them in workflow so that you can choose one of these findings, and in those actions, you can invoke these custom actions that you've defined. This will in turn trigger the step function or the Lambda that you've defined in the custom CloudWatch action to take that response or remediation, hence making it easier to orchestrate that workflow for the customers. So bringing it all together, this is where we wanted to make sure that customers have the ability to simple and scalable security monitoring, threat detection, as well as continuous monitoring. We continue to scale our existing services. We've now added in Amazon GuardDuty the EKS protection earlier this year, and then just today we launched the GuardDuty malware protection. In Amazon Detective, we today announced the Detective EKS investigation coverage that allows you to leverage the graph model, the behavioral graph model of Detective, and investigate Kubernetes instances. And then in Amazon Inspector, we've added support for ECR in addition to our instances to find out and highlight any vulnerabilities using the continuous scanning of Inspector. All of this can be continuously monitored and aggregated into Security Hub, which is where you can automate response actions. So hopefully that provides you an overview of our threat detection monitoring and what's new in these services. Stay tuned for more in the future sessions. And then if you're around in TDR 204, we will cover the top 10 ways in real life examples customers can actually operationalize security incidents. So join us for that session tomorrow. Thank you.